Ladies and gents, welcome back to another Engineers podcast. Today we're joined by Rok Erjavec. He's a VP of Engineering at TomTom, a nostalgic podcast for me and for probably quite a lot of people listening. They're well known as being market leaders in creating mapping and location technology. And I think for a lot of people growing up, this was a mainstay business in a lot of vehicles, traveling to unknown destinations. These guys and girls helped build some incredible hardware and software that got you from point A to point B. So we're going to be talking about that quite a lot over the course of today. But mapping and location technology is, I think, a really interesting space. We're going to be speaking about that. We're going to be speaking about map visualization units, geospatial data, and some of the engineering complexities around that. So, Rock, first and foremost, thanks for coming to join us.
Thank you.
Give us an intro on Rock's background and where he comes from.
Sure. So I'm actually relatively new or old to the geospatial technology, depending on how you look at it, because I've joined TomTom about 2.5 years ago. And before that, I spent most of my 20 something years in tech, uh, in games, actually, like majority. There was a few other stints in there, but gaming really made the bulk of it, where I worked across game developers and different major publishers from Ubisoft to Electronic Arts to some of smaller startup companies. Also, Crytek was in there somewhere for those from Germany listening. Uh, but yeah, it's been like a fairly lengthy career. Starting as a software engineer, like so many of us that end up in leadership roles later. But the reason I mentioned I might be old to the location tech is because my very first job, straight out of, well, while I was still in school, actually, was working for a mapping company back in my home country. And that was fairly brief, but and we were doing on a much smaller scale maps for a local region, like planning for real estate and things like that. But it was working with map data, so I'm not entirely new to it. You could say I can come full circle in a way. Um,
Nice. Good background. I can now see the ties between gaming, mapping technologies, building latency critical services for users. We'll talk about some of that. Um, I think it would be a really good place to start to talk about a bit of an evolution with TomTom and what we were discussing offline. So I'll give you the floor to talk a little bit about the shift in TomTom.
mhm. Yeah, so as you mentioned, TomTom also has a long history of its own, starting as basically the inventor of mobile navigation as we know it today. But that market has, over the years, evolved quite significantly itself with the invention of mobile phones that everybody has and so on, that are quite capable of doing that functionality on their own. So that also had ramifications for the company we're at now. And over the last decade or so, TomTom has transformed itself into much more of a software and services company rather than being hardware focused. To be fair, we still produce hardware units to some extent. They're just not a major business anymore compared to where it was at the beginnings. However, our major business has very much moved into the space of providing both the services when it comes to mapping and geospatial tech to other businesses, but also building software, both end user software. We have some apps that you can download on your mobile phones yourselves, but sometimes entire software solutions for our business customers as well. This is usually in the form of like automotive customers where we might build big portions of the navigation stack or entire solution there that you see in the dashboard. But also other types of companies. We really work across the spectrum with companies like Microsoft and Meta and others on different type of engagements. So that's maybe like a elevator pitch of where the company is today.
No, good. I did touch on my intro about the map visualization units. Can you explain that? Can you explain the unit and can you explain what the teams actually
Mhm.
do?
So yeah, maybe actually one thing that I would add as a lead into what map visualization and why it's important to us is so one thing that TomTom does today is this was announced I think about a year ago. Now, if I'm not counting wrongly, with the announcement of our new mapping platform called Orbis Maps, and the focus of that is really the interoperability of the platform. Creating a foundation both for the range of services we provide, which is all the navigation stuff. You think about search, routing, traffic, visualization, automated driving services, and more. But also providing this as a platform to the rest of the industry to collaborate together. There is a behind that is what you might have heard about Overture Maps, which is a foundation, open foundation that was created by TomTom, Meta, Microsoft, and Amazon, and it serves as an open stack to build essentially the map fundamentals on. So it's a little different from your OSM products, which are like community driven. This is industry driven, but it is still open source. It's a proper Linux Foundation powered project. I guess you were not aware of this one. So
I wasn't. And what's really the purpose of the open sourcing or the collaboration there? What's the thinking behind
Mhm.
that?
so the thinking is really that as an industry, we've been moving more and more towards a point where it becomes evident that there is a lot of commoditization going on, where every map out there proprietary that is being built by different companies has to offer certain base levels that are across different products the same, because everybody expects that to be there. Um, but then the other part is that it is building a complete map offering like that is it's an enormous undertaking for any one company. Even the dominant players uh, are spending a lot on that, and it's a non-trivial thing to maintain. And some companies have tried and backed away from that in the past because it was just too costly for them to keep investing. However, everybody is interested to have that baseline work off of. This is when the open source foundation comes into, like, we can all essentially join forces on a common standard with a common topology of the road network and a couple of other baselines, and then you build on top of that, where you get custom layers and offerings for your particular products, like, that can be unique to each company. um,
Got you. Those common standards, I think, are interesting. You're dealing with some major players here. Um, and you're right. I imagine it is an enormous undertaking. And is the plan really to use that mapping data as the four companies who make up this, if you like, open source mapping committee? Or is it to potentially white label this software as a service, to sell this to businesses, to be able to use this as a foundation, to be able to build their products on top of?
so the overture itself is open to anybody, and there are other members now. The four founding members are just the companies that created the foundation, but we already have others that have joined recently, like Niantic is one of the big players that just signed up in recent months, and there are others. You can find the announcements online. um, but then when it comes to the commercialization of this, it's like, like with any other open source platform, companies will take this and build, and they have the option of building offerings that make sense to their type of markets or customers. In our case, we have a lot of value add layers that are TomTom proprietary, and they are still sold with our TomTom product, which has Overture under its hood as a base. Uh, that is how you can think about it. And that, yeah, obviously any company can then choose to take that route, or work with any of the existing offerings that are already there that are Overture based.
Got you. Okay. Talk to us a little bit about the map visualization
Yeah.
units then, and what do the teams specifically
Mhm.
do?
So this is what I was going to say. Map visualization is important to us because it's the face of the product. Essentially, it's the first thing people see. So when we can talk all day about how great the map is, how modular and extensible it is, and real time it is, but if you don't see it with your own eyes, then that's just numbers and words. So MapVis really comes at the focus as a first entry point for any customer or potential customer. That's why we, as a company, felt the need to have a dedicated unit that is, focused on this aspect. And what is MapVis? It's essentially uh, a full stack collection of technologies and services. So people hear MapVis and then think, oh, it's a renderer. It's a map renderer. It's map customization. Well, that's just one of the aspects, right? Actually, the unit as a whole starts with ingestion of data, which ingests like the map itself, but also other types of data sources, like you have your satellite data, your elevation, and any number of other sources can come into play there. And then that gets processed and converted into formats that are actually optimized for visualization and delivery of such data to client devices. And this is then served through our set of services, which we call, like, for example, we have a vector tile map display service, which essentially is where you go when you want to download vector tiles that represent your map. There are other endpoints that we have in the stack as well. Again, like satellite coverage and other things are also where you go through our endpoints to download them. And that you can use directly as a customer. You can just literally access APIs yourself and do stuff with the data, whatever it might be your use case. Or, which is the where other parts of the product come into play, you can use our SDKs, which then include things that manage downloading and serving of this data for you under the hood, but then also offer the actual visualization services that run on a device or on the web browser or somewhere else. This is also part of the teams that sit within MapVis. And then surrounding all that is, of course, the tooling, because the best technology is only as good as the tools that you give people to work with it. And that's where it comes to, like, how do you customize the look of the map? How do you make it your own, or you know suitable for a specific purpose? Remove things that you're not interested in. Add proprietary layers that you may only work within your company with, and so on. That's like a brief rundown of what MapVis is all about.
Okay, I've got you. What do you think are some really key and critical engineering challenges that sit inside of the map visualization unit? Because there's a lot there around data ingestion. There's a couple of things there that I hear in regards to tooling. And as I'm speaking, I've got a vision in my mind of how complex that looks, but break that down for us and help us understand what are some of those engineering challenges? How do you go about solving them?
Yeah, so the interesting thing about this space is that, yeah, we deal with both sides of the challenges. On one end, you have the data processing, the scale, the services, which is your, more typical things associated with working with online backends, and how do you serve many millions of customers or requests at scale. And on the other end, we have the highly optimized backends for rendering, which are supposed to run real time on a device optimally for both the performance and user experience, but also like thinking things like keeping things like battery life in mind, and so forth, because and it has to be highly configurable to run on many different platforms. Because while mobile devices are an easy target, we also work, as I mentioned, with many customers that have their own hardware, like in cars or other types of devices. So So yeah, it's two different sets of problems, and in the middle, of course, is the tooling, which is probably the third pillar that is super important because again, usability and ease of use, speed of iterations, and all that is very important to make this stack functional for many different types of customers. And each customer really cares about how quickly they can really iterate on their products.
Well, what does that process actually look like of geospatial data? And what you said earlier is it would just look like a whole bunch of numbers. If we just had that geospatial data, like that process of taking that data and creating map visuals, like what does that actually look like?
Yeah, so maybe we can use numbers to start with to represent it a little bit, where a typical ingestion of a map uh, contains like I think we have like 1.7 billion map features that get processed for every release, and out of that ballpark, we probably keep around 600 million of them for actual use in the map viz today, because not every feature is actually relevant to visualization. So that is part of the processing, and just isolating the things that stay for map viz and converting them into the right representation. In terms of data inputs, I guess that works out like the total map database is around 5 terabytes that you process there. But there are also other one-offs like satellite maps. They don't get processed that frequently. We probably do it like once every couple of quarters because they are not updated as frequently. But those are also multi-terabyte databases. Then there is more real-time sources that come into play, which is like our traffic data. It's probably more famous because lots of people know that the TomTom traffic index, and that is continuously processed. Of course, it's not on a per release basis. And then, yeah, I guess map gets today updated about twice a week. However, we are working towards a real-time map as part of our paradigm, and eventually we plan to be in minutes from a map change to a device. So when somebody edits a map, you should be able to see it in a map on your device within minutes. That is our final goal, actually. Yeah.
That is absolutely insane to comprehend that there's a map change to within minutes there is a, let's say, real time change. That is nuts. Compare some of the size and scale of the data at TomTom to, let's just say, normal data ingestion, so that we can, not necessarily at TomTom, let's just say at another business, so we can actually comprehend some of the scale that you're actually dealing
Mm.
with.
Yeah, that one is contextually a bit difficult for me because most of my experiences, like I mentioned, were in very different domains. And games, they're not your typical business side. um, but the data processing there is done in a different manner. Like there's less ingestion because you're doing it more incrementally. Um, the total data sizes can still end up actually multi terabytes for a project there too, but you're not ingesting that as a whole ever. You're kind of incrementally building it. So on a daily basis, you're processing smaller amounts. But yeah, it would be interesting, I guess, to compare to other types of businesses. But I don't have that granularity of numerical comparison that I could share right now. I think with it.
Fine.
Um,
Let, let's park that. Let's just go with it's massive. Um, I think it would be really good to get under the hood and just understand maybe process and technologies. First, with process, like how are you actually processing, ingesting, cleaning, using this data, like that process of doing that end to end? And it would be good to marry that up with technologies, as in helping people understand the technological environment and some of the tools that you're using and why you're using them. Because I think that understanding and that overarching picture of what the environment looks like could be really interesting to some businesses who could go on and embark on almost this data transformation journey, if you
Mhm.
like.
So yeah, actually, this part is where we have a lot of homegrown software that's specialized for the different needs of types of data that we work with. Because you have to remember also our maps started as a completely proprietary data stack. Even though now we have more industry standard sources in there, it wasn't always the case. Uh, but yeah, essentially, the stack that runs this processing today, it's essentially it's built on AWS batch jobs. So we run hundreds of these jobs work workers in parallel. I think the way it's designed right now, that scales to tens that run for each country, because parallelism is like geographically distributed, but then thousands in when you run across the world. And that allows us to then take this process roughly within 5 hours of a single run to complete, even with all this parallelization. Of course, if that ever becomes a bottleneck, we can try to scale it more granularly and further, but that's where we are today. For that minutes thing we talked about, there are also other techniques than parallelization that come into play, because it can become more incremental in how you treat changes as well. And yeah, that's like I said, the 5 hour is about one run for a map. We consume multiple map sources today because we still have a legacy map and the new Orbis map. So we're not running just one of these per week. We're running several. Then there are, of course, the test runs as well, in addition to the production runs. So overall, it's probably like a dozen compilations per week that you might see within one service like MapVis.
Okay. Tools and technologies break that side down to help us understand the stack and the choice of why you actually use some of those tech and
Mhm.
tools.
Yeah, so I mentioned AWS, and I think that one doesn't need a lot of introductions, given that it's one of the three biggest cloud offers on the market. We don't just work with AWS; we do have Azure services as well, and we try not to be too cloud specialized there. We're just trying to use the best tools for the job, essentially, and AWS batch processing was chosen for that reason. Um, but then other tooling that comes beyond the data pipelines. So a lot of the language that is used to build these jobs is, well, we mix the two things. We have Java for a lot of the batch processing on the ingestion, but then we also have a lot of C++ on the tiling services and the actual backend that runs runtime requests and so forth. The rationale there being that, well, some of it might be historical, that C++ was used when the company was still in growth phases, but also there are optimizations you want to be doing on your backends that are real time, serving requests to actual users, like can be in billions per day or week. Those you want to run as cost efficiently as possible as well. So there is that. Likewise, for our runtime stacks that run on devices, the homegrown technology was also all C++ based. This is similar to why game engines run C++ most of the time. Again, you are very focused on performance optimizations, fine grained control of memory usage, things like that. The More recently, we started also opening this up a little bit. So we are no longer working with just our proprietary stack. We have started looking at, and this is where we go into the game related fields. Because when you really break down the question of how do you visualize or rasterize a map, the problem space is very similar to what game engines are trying to solve. So we are now also experimenting with game technologies in our delivery of actual visualization. And I think if you look at some of the marketing materials that have been shared since the CES this year, most of those visuals are directly from the real-time product that you can run on your device. Those are not some handcrafted art, like optimized marketing materials. Those are just directly captures from the product itself. So this is what you see, what you get. And we can go a little bit deeper into why the game technologies are interesting to us, but that topic is a little longer. So I just wanted to skip a little before I go there. We have the third pillar, the tools, where we mostly work with web technologies today. And the simple reasoning for that is that you want to have something that is a low barrier to entry. So a designer can go in, log in into their web tool and just start playing with it. Minimal friction. You don't need to install software. You don't need to jump through special hoops. That allows the end user to be quite flexible. But then at the same time, building tools with web technologies also has certain advantages where when it comes to previewing things at real time, there's a lot of relatively mature tech stacks in the web that are allowing this to be done quickly, and it allowed us to go a bit faster on that.
Yeah, got you. This is a bit of a side note. It might take us down the gaming route. C++ still a widely used technology, um, maybe not being introduced by companies that are being built, let's just say, in the last 5 years, unless they are trading, high frequency trading in particular, hedge funds, let's just say trading platforms or gaming platforms generally. C++, do you think it will continue to be a mainstay because of some of the use cases that you've mentioned? Mapping, geospatial, gaming, trading, etc.
I think it has a place. Yeah, I think. Well, C++ is one of those things that has continuously proven naysayers wrong. Right, for all of its history, there was arguments for why not something else, but it remained not just relevant but kind of dominant in certain spaces for what 40 years now, 30 give or take. Um, but yeah, I believe it will remain relevant because the costs of actually runtime compute are still, well, if anything, they're more relevant today than ever, because even if you're building purely cloud uh, infrastructure and software for cloud, any cycle is basically dollars that you're if you waste it, you're wasting dollars, right? So that level of fine-grained optimization will remain important, and today C++ is still one of the best tools for that job. It's not the only one anymore, but there is also a large pool of expertise there that you can leverage. So
And you need to think about that as well. The expertise to be able to use the tool in the right way, um, to harness some of the power of why you would use that language needs to be there. I know Rust is coming to the fore quite a lot, still relatively new, but widely being used in trading firms, other places. So I'd say Rust has definitely got its place
yeah,
now.
yeah, Rust has been on a very interesting growth pattern, and we've been looking at it and talking about it in different industries since I remember. Yeah, it's been, again, probably plus decade plus that I remember discussions around it. Um, and it's always like an interesting thing where you look at it like, should we start switching some things over, or just experiment with it a bit. Younger engineers are always excited to try it out. So for sure, I think it's proven its place, and it's also likely to be around for a good long while. Yeah.
Yeah, I can imagine. Okay. Um, the mapping visualization unit, we've spoken about a lot. We've spoken about ingestion of large volumes of data. We've spoken about how you might actually ingest the data, process it, the tools and technologies. It'd be good to get a sense of the people in that unit and what they actually do on a day to day basis, because I'd love to then come on to how TomTom's continuing to grow. and what that growth might look like. So let's focus on the team itself and who are those people in the team? What are they
Mhm.
doing?
So by and large, we're an engineering heavy organization. Yeah, it's probably like 90% of the people in the org are engineers, and then the rest is then spread across other disciplines where you have your quality assurance, you have uh, the UX designers, product managers, and of course the management layers. We can't forget those, even though we like to think ourselves as engineers still once we shift to management. Yeah. Um, but yeah, day to day, we are broken down very similar to a lot of modern tech companies into teams that are roughly 7 to 10 people large. Sometimes they are a bit larger, sometimes they can be a bit smaller, but that is the average number you're looking at. And then each of these teams typically owns either a product or several products or a tech stack. We are positioning them more product facing or product aligned than stack aligned, because historical lessons teach you that if you have all the teams stack aligned, you end up with products that usually intersect all the stacks, and then it's very hard to build those efficiently. So we've been realigning teams to be more product aligned, and that's actually worked out pretty well within this org. Uh, Last 2 years of transformation have gained us significant efficiencies by doing this. Um, and yeah, day to day is then you have your engineering teams that get either requests or they have their own roadmaps that they're already building towards, targeting milestones that are often very customer centric. We are customer centric as a company, although our customers are usually other businesses, not necessarily end users, but still. And yeah, like maybe ask follow-ups if you want to know like details specific to the workflow or something else.
No, I was just keen to understand who and how the function is actually made up. You touch on an interesting point, and I think it is interesting to see the evolution of TomTom. Not that I knew how the teams were structured, but it very much is now a structured modern technology company. And you were talking about the shift of or shift to B2B, which I think is interesting to see. Help us understand a bit more about where the business is going to be growing over the course of this year and what talent you might be looking
Mhm.
for
Yeah.
and why.
So we're definitely hiring. If anybody had doubts, I know the industry has not been in great shape these days, tech in general. But yeah, TomTom is hiring, and we are expanding some areas still quite aggressively. Um, but overall, yeah, I mean, we are a publicly traded company, so if you want to know projections and business objectives, those are there for public consumption. So I'm not going to waste too much on that. But we are still very much committed to our automotive businesses, which are a strong foundation for us to grow on. We've had some major uh, deals that have been made in the last year and a half that are in production now. We are always, talking to more customers. There are some prospects there that hopefully pan out as well this year. So that growth is expected to continue. But then the other part is that we are expanding as well into other industries, right? What we call the enterprise, which is essentially anything that is not covered by automotive clients are enterprise business customers, and that can really be anything. It's I would hesitate to point them to any specific subdomain, because today that might be like a company like Microsoft that does their own services on the back of TomTom data. Tomorrow, maybe somebody like Booking.com would work with us. Well, it would be nice if they did.
Okay.
Um,
What would be a use case of Booking.com to come and work with
yeah,
you?
so if you go to a site like Booking.com, you will see that there is a search with a bunch of parameters, and then they usually have an embedded map of some sort, or you can click and get the embedded map view, and that helps you to, as a user or the customer, to get your bookings through, right? So they rely heavily on location data. They have their own sets of data that needs to be indexed on the map as well. Sometimes real time, sometimes other layers that need to work nicely with the map provider that they've chosen. And then they have map visualization, of course. So um,
I've used their functions, and I'd be really interested to draw that parallel by the map visualization data, introducing that and the increase in revenue, because I know that I've made purchases, travel purchases as an example, based on the location. So that's probably quite a good indicator of where the map visualization data or how the business has actually shifted, that use case specifically. And I'm sure there's hundreds
yeah,
more.
yeah,
Uh,
exactly. So last year I was at an event with Unity where they invited me to also be at the round table to speak to industry, other industry companies they work with, and TomTom also uses their technologies now. Um, and there was an interesting array of different companies working with Unity. But what fascinated me most was that many of them also work with location tech. So, like, there was an airport company that essentially is, a geospatial overview of an airport that then overlays all the real-time inputs from monitoring an airport onto it. And you could easily envision how that could scale to an entire world map where all the airports are there one day, that way accessible to a user, right? For example.
okay, interesting, interesting. Okay, well, we're going to wrap this up. It has been nostalgic in the sense, like I said, I've been a TomTom user um, in the past, so I've felt the product firsthand. Like I said, it got us from A to B. Where I was a lot younger, and unknowingly, I've been using the product over the last few years in a B2B setting. So it's great to see the transition of the business. This is what I love about the podcast. This is what I love about this community. You unknowingly use a lot of these really amazing products. Rok, thank you so much for coming to join us, first and foremost, and share with us a little bit more about map visualizations and the amazing work that you guys do to get that onto our screens, devices, and everything else. Um, a big thank you from the community engineers, and for people listening, like, shares, subscribes. Like Rok said, they're hiring. Career sites below for people to check that out, and no doubt reach out to Rok directly to understand more about how you can actually go and work with the team. Rok, a huge thank you from us.
Yeah. Thanks for having me. It was a pleasure speaking as well.
Absolute pleasure. And like I said, likes, shares, subscribes, they're all appreciated. And it's bye for now from us. Hey guys, thanks for watching this episode. Massively appreciate you listening and checking in with us. If you want to find out more about us and what we're doing, please check us out on social media. What we're trying to do at Engineers is build a community to drive knowledge sharing and experiences. On Twitter, we can be found Engineers.io. It's no_. We've also got a website, which is engineers.io. These links will all be posted in the description. Any feedback and comments are massively appreciated. We're always looking to improve on where we can. Thanks, guys.